Bonjour. That's all I know. So, well, actually, okay, so I started Duolingo, and I started it 2 weeks ago. So I can give you all of the French that I know. C'est un cheval. Tu manges une orange. That's it. That's it. Thank you. Thank you. Thank you. For those like me who don't speak any French, I just said that's a horse, and you eat an orange. So we are really setting the bar here. Thank you guys for being here. I know it's 5 o'clock. We're going to make it live. They told me I can't move around, which is going to be hard for me, but we're going to get the energy. OK. Hi, everyone. I am Shaundai Person. I'm a senior software engineer at Netflix. And today we'll be talking about Remix and how Remix makes your apps more performant. OK? Is there anybody who has used Remix or is using Remix right now? Awesome. Awesome, my people. OK, great. So when we say an app is performant, what we mean is it's an app that our users can see and interact with as quickly as possible. And essentially, that's how we measure it, too, right? So consider actual performance metrics, like the ones that the Google Chrome team uses, Core Web Vitals. Metrics like largest contentful paint and first input delay all help us to understand, when a user comes to our page, how quickly are they able to see what they expected to see? How efficiently and reliably can they do what they came to do? Now, tech has evolved so much in the past few decades. Computers have gotten faster. Browsers have gotten more sophisticated. An app that 10 years ago would be considered top of the line because of a 20-second load time, today would be considered atrocious in terms of performance. Yet and still, and always, the question will be, always and forever, how do we make our apps even faster? How do we make our sites more performant? Now, React originally approached this problem with the concept of the virtual DOM and client-side rendering. So how does this make our apps faster? Well, rather than manipulating the actual DOM with JavaScript, which can be pretty expensive, we minimize the performance costs of re-rendering a page by using the virtual DOM to handle things like component lifecycle updates and batching. So client-side rendering is the way that React does it by default, and this is how it works. So in a client-rendered app, all of the instructions to run your code are held inside of a JavaScript script tag. When a browser receives a request for a page, like when your user comes to your page, we first initiate a request to the server to get the data. And then once that comes back, the page will send the HTML, the CSS, and that script tag over to the browser to be run. Once it's run, your site is fully interactive. So that means that your modals will open. Your Netflix movies will play, for example. And also, once we have that information from the server, now navigating between routes is just refreshing the DOM with new information. So clicking through routes within your app actually appears lightning fast for your users because we are just updating the DOM with the new data or the new state. Okay? So yes, this is a performance enhancement over manipulating the actual DOM. But client rendering has its problems. And that's because as we continue to add more and more features to React and to React frameworks, we're adding to our JavaScript bundle size, OK? And as you can see, until the JavaScript is parsed and run, all your users are able to see is a blank page. If you have a heavy amount of JavaScript, it will take some time, and your user is stuck for several painful seconds, even sometimes minutes, with just a blank white screen. So that's where server rendering comes in. And server rendering doesn't solve the problems of these large JavaScript bundle sizes. But what it does do is it gives your user something to look at while the JavaScript loads. So server rendering works like this. On initial page load, when a browser receives a request for a page, on the server, we'll fetch the data for your entire application. And then also on the server, React will walk the component tree and render all of your components as HTML. And that will send that HTML over to the browser for your users to see. So already, server rendering is providing a better experience for your users than client rendering would, because we haven't loaded the JavaScript yet, but your users aren't stuck looking at that blank page. They get to see your content as bare HTML. But keep in mind, server rendering is not enough to give us a complete website. Because yes, your users can see the content, but it's HTML. And they didn't come here to see non-interactive HTML. They can't do anything with it. So we move on to the next step where we load the JavaScript and we attach it to the HTML that's already in the browser. This process is called hydration. Once hydration is complete, your app is interactive. So now you can watch your Netflix. Okay? Now, this is an optimization on client rendering because your users aren't looking at that blank screen. But now we've introduced another performance issue, a new one. Because anytime we click between routes in our app, we have to kick off that process all over again and run through all of those steps all over again for each page, making navigation between routes in our app seem not as performant. So we have this trade-off. Do we want our users to have that lightning-fast navigation between routes like we get with client rendering, even though they'll be stuck with that blank white screen for a couple seconds or even minutes? Or do we want that seemingly fast initial page load where we get to send the HTML to the browser while we wait for the JavaScript to load on initial page load, like we get with server rendering, even though as we navigate between routes, it's not going to seem as performant? Well, what if we could have the best of both worlds? And that's where Remix comes in. Remix, out of the box, gives you server components that allow you to take advantage of the properties of a server-rendered app on initial page load, and then adopt the qualities of a client-rendered app as we're navigating between routes. Not just that, at every step in the rendering process, Remix provides optimizations that get us to hydration quicker, which means that we get to interactivity quicker, which means your users get to watch Netflix faster. Okay? So here's our example app. Let's talk about how this works. Our outermost component is a layout. Our layout has two children, a nav and a sales pane. The sales pane has two children, a header and an invoice list. And the invoice list has one child, which is an invoice. So this is what our actual app is going to look like. Okay? If you've ever been to the Remix website, this is the example that they use. It's an invoicing tool called FakeBooks. Okay? So our components are a side nav, a very simple top nav, and then our two largest content components are a list of invoices and then the details about our invoice. For simplicity's sake, let's just use boxes because as front-end engineers, that's all we pretty much do anyway, right? So let's talk about how Remix is going to provide us with optimizations all along the way. And let's start with initial page load. This is where Remix adopts the properties of a server-rendered app, because remember that server rendering is the optimized way to do things at this step. So we'll go through all the steps of the server-rendered process, and we'll talk about how Remix is going to provide you with the optimizations. The first step is where we fetch the data. So this is where React will walk the component tree and fetch the data for all of the components that will be shown in the DOM in the order that they appear in the render tree. Okay? Our first issue is already here, so our first area for optimization. We have these fetch waterfalls. And this stems from the fact, or request waterfalls. This stems from the fact that we have to walk the component tree and fetch the data for components in the order that they appear in the tree. And it's kind of like a relay race where we have to fetch the data. Let's use an example. We have to fetch the data for the nav. And then once that's finished initiating and fulfilling, then we can fetch the data for the sales pane. Then we can fetch the data for the header. Then we can fetch the data for the invoice list, and so on and so forth. Now, this causes two issues. The first issue is that our parent components block the children from initiating their fetches. And if you have a parent component that has a heavy amount of data, it's going to block their children from initiating, and all you'll see is loading spinners in place of all of those children. So imagine in the real world, right? Like, imagine if you go out to eat with your kid, and your kid has to sit there and watch you finish your entire meal before they can even get served their plate. Toxic, right? Like, that's not healthy. That's not healthy. Okay? So that's our first issue. Our second issue is that components with heavy amounts of data block the other components from initiating their fetches. Like the sales component, for example. It acts as a bottleneck for the other components and elongates the process all together. We have a second issue, and this issue stems from the fact that we have to do round trips between client and server. And the reason this is the case is because in order for the server to understand what it needs to fetch, the client needs to be able to tell it what data is going to be shown in the DOM. So the request is initiated from the client, that request goes to the server, and then the server sends back a response. Now, if your app is non-trivial, if you have a heavy amount of data, this can take some time. And it's especially problematic for your users with slow internet connections, where this response takes a long time. Keep in mind that even with a server-rendered app, we can't move on to the next step of the rendering process until the data has been fetched. And remember, server rendering is the part where we're optimizing because we're showing that bare HTML, right, instead of that blank screen. So we're not able to get to that part where we're rendering the HTML until we have finished fetching the data. So this is going to stop us, clog us up. Couple that with our third issue, which is that our request logic is on the client. Again, problematic for your users with slow internet connections. We can't control the speed of our users' internet, but we can control how much data we put over the network. And in this case, we're putting a lot. So let's use an example. Let's say that your user wants a list of invoices, but they only want to filter down to see the invoices that have been billed over the previous quarter. So we make a request from the client and say, hey, I only want invoices from January 1st to March 31st. And that request goes to the server. The server says, hey, listen, the way this API is set up, I have that data, but I also have a lot more. So I'm going to go ahead and send you everything that I have. And it sends literally every single invoice that we have in our data store. For your client who has, I know I can't move, but I want to so bad. I want to just show you OK, this is what it's going to look like. So you take this heavy amount of data, and for your poor user who has slow internet connection, we're sending this heavy amount of data over this very slow network, OK? Again, we can't move on to the next step until this data step has been completed. So that's stopping us from doing that. Add to that now our front end is responsible for all of the heavy computation. Because now we have this fulfilled request for every invoice ever, right? But that's not what the user asked for. So now your JavaScript is responsible for filtering through all of those results. Let's add like a dot filter or something and just show the list of invoices from January 1st to March 31st. So that's going to extend the time that it takes for our JavaScript to run and elongate the process altogether. Luckily, Remix has fixes for all of these. So let's go back to our first problem, where we have this kind of fetch waterfall, this pass the baton, walk the component tree, fetch the data for each, right? Remix handles this by giving us the ability to parallelize our data fetching. So in Remix, this is very fundamental to the way that Remix is set up. The way that Remix is structured is that each component is coupled with a part of the route. And watch how the highlighting of each component changes with the color of the URL that it corresponds to. So each component is coupled with a route. Each route has its own fetching logic. And Remix can tell, just from looking at the route, what data needs to be fetched. And that can be done all in parallel. So what happens, when, who's saying wow? What used to be a fetch waterfall like this now looks like an abbreviated version like this, OK? So we've solved our first problem. Remember, we had our second problem, which is that we had round trips between the client and the server. Now remember, because Remix can tell just by looking at a URL what data needs to be fetched, we're able to initiate the request from the server. So we can initiate from the server and just do a one-way trip from server to the client. So we don't need to worry about those round trips. Much faster for your users who have slow internet. Great if your app has a non-trivial amount of data. So we've solved our second problem. And then remember, our third problem was that our request logic was on the client. Now, because Remix gives you server components, we can put that logic on the server. So let's see how that works with the example that we used where we're filtering down just a list of invoices from the previous quarter. We're going to go ahead and make that same request from the client and say, hey, server, I'm just looking for invoices from January 1st to March 31st. Now this logic is on the server. So the server is smart enough to know that I'm only going to send you this data. I'm going to do the filtering on my end. And it's going to go much faster because we're doing it on the server. And then we're just going to send that little bitty bit of information back over the network. And your user with a slow internet connection benefits from a much happier, much quicker experience. And we don't have to run all that computation on the front end with our JavaScript. So we've solved our third problem as well. OK, that was our first step. Now, let's get to the second step where we're rendering our app as HTML. Remember, this is where server rendering is providing an optimization for your users because even though we haven't loaded the JavaScript yet, your user is not looking at that blank screen. We're going to generate our HTML, and then we're going to send it to the browser for your users to see. Now, the problem here is that most front-end apps are heavily concentrated in JavaScript. We're using JavaScript frameworks like React. We're using React frameworks like Next. And so it limits, because they're so concentrated in JavaScript, it limits what we're able to do at this page. Remember, this is just HTML. And so when we center most of our interactivity around JavaScript, it only gives your users the ability at this stage to do what you've structured your HTML to do. And most folks aren't putting a lot into their HTML. So your user may be stuck, especially if your JavaScript has a large bundle size, may be stuck with content that they can see, but they can't interact with, right? Now, Remix has a different philosophy, and their philosophy is to lean into the fundamentals of the web. And by the fundamentals of the web, what I mean is browsers, HTTP and HTTP caching, and just plain old HTML. And so what that allows us to do is it gives your users so many more options at this stage. Remix uses HTML as the basis of the framework. Okay? Now, I am a JavaScript woman through and through. I am not advocating for not using JavaScript or not using React, and it's perfectly fine and capable to use React and JavaScript with Remix. In fact, it's recommended. But what I'm saying is that rather than JavaScript being the full meal, JavaScript is just the little seasoning on top, and you can use it as needed. Okay? All right. And then our next step is where we're loading the JavaScript. So again, we get to that same issue where we have apps. Again, as we're adding more and more functionality to things like React, we're adding to our JavaScript bundle size. So remember, your user at this stage can be stuck for several seconds with content that they are no longer interested in and can't interact with. Once we have the HTML in our DOM, React begins this process of hydration. And rather than creating new DOM nodes, React will walk the component tree and attach the event handlers to that HTML that's already in the browser. So this process of attaching the logic to the server-rendered HTML, that's hydration. And then once hydration is complete, that's when your app becomes interactive. Now, with most apps, most web apps, since it's so heavily concentrated in JavaScript, it takes us a long time to get to hydration because it takes us some time to load that JavaScript. A lot of the JavaScript actually in most web apps today goes into things like data mutations, data fetching, error handling, and loading. This is just an example of a form, a very simple form, in fact, but it's flowing off the page, right? Remix is different, and here's how. Again, Remix leans into the fundamentals of the web, and they give you those capabilities right out of the box. And what they're using is web APIs under the hood. So your your app comes bundled with much less JavaScript. So we get to load our JavaScript much more quickly, and then we're able to hydrate our app much more quickly. So we solve this problem by, instead of calling Remix a JavaScript framework, we're calling it a web framework. So we solve our fourth area for optimization. OK, and so let's move on to the last step of server rendering, which is hydration. And so once hydration happens, your app is interactive. So again, you can watch your Netflix movies. And because we've optimized at every stage of the process, we get to hydration much more quickly, which means we get to interactivity much more quickly, which means that our users are happier much more quickly, right? OK, so that's initial page load. Now, let's talk about how we navigate between routes. And this is where Remix is going to adopt the properties of a client-rendered app. This is important because, remember, server rendering, the area for optimization was when we're navigating between routes. If we click another route, we're going to have to kick off that rendering process all over again. So once we've hydrated, Remix will store the CSS, the data, and all of the assets of the page in memory and in cache, just like a client-side app would. Okay? Again, if you weren't using Remix, we would have to kick off the entire rendering process. So let's use an example to illustrate this. Let's say that our user just wants to click away from invoice 500. They want to show invoice 501. So the only part of the page that will change is this part of the page. Again, if you're not using Remix, if you're using standard server rendering, clicking to show a new invoice is going to kick off the server rendering process. And we'll start by fetching the data for all of the components that will be shown in the DOM, starting from the top of the render tree and working our way down. And then we'll go through all the steps of the server rendered process. Now, here's another advantage, again, to the way that Remix handles data. Because, again, Remix knows just by looking at the route what data can be fetched. And we can fetch that individually. We don't have to fetch the data for our entire application. We can say, hey, Remix, I only want invoice 501. And that's all the data that we'll fetch. We'll fetch just the data for 501. And again, send that little bitty bit of data over the network and off to your user's browser so that they can see. Now, here's where we're adopting the properties of a client-rendered app. Instead of removing all of the JavaScript and the CSS and all of the assets from the page when we navigate between routes, all of that is stored in memory and in cache. So once we have that updated data from the server, we just refresh the DOM with the new data and use the JavaScript that's in memory. So navigating between our routes is lightning fast, and your user is getting the best of both worlds. Lightning fast initial page loads and lightning fast navigation between routes. So we've optimized 4 main areas on our React app by using Remix. I saved the best part for last. Well, my favorite part, OK? Because Remix has your component asset manifest. And what I mean by that is just by looking at a route, Remix can tell what data your app needs, what JavaScript you need, what CSS you need, all of your assets. We're actually able to pre-fetch all of the information for your user before they even click the link, OK? So by using this prefetch prop on a link tag in Remix, it indicates to Remix to look out for hover activity. And if your user hovers over a link for a certain amount of time, we'll kick off the fetching of the data for that page, and we'll kick off the loading for JavaScript and all of the assets. From your user's perspective, it seems like your app is instantaneously interactive because the parts of the app that they want to interact with are interactive instantly, the way that they want to engage with it. OK? Imagine in real life, right? Like, let's imagine that you are looking at shoes online, right? You're just looking at shoes on your phone, and a couple seconds later, your spouse comes in with the pair of shoes in hand that you were looking at in your size. And they were like, hey, I noticed that you were looking at these. I thought you might like it, you know? So Remix acts as kind of like a concierge for you, acts as a concierge for your users. You, as the developer, have this simplified process because Remix handles all of this out of the box for you. And your users are able to benefit from the properties of the server, an optimized server-rendered app, as well as on navigation between routes, an optimized client-side app. And it feels catered to their needs. So whether your user is on high-speed internet connection or whether they're working from the Alps somewhere, your user gets to benefit from an app that seems just as fast as the internet. Thank you.